just all over the map. I am really not liking this meter. That's really unfortunate. I love Klein as a company. I love their tools. I even love their other meters. I am not a fan of this meter. I'm so disappointed. All right, folks, welcome back to another adventure in the garage. And for those of you that are new to the channel, my name is Luke, and today I'm here to help you sort out all of the different test settings on your Klein MM300. And if you're anything like me, you went ahead and bought the kit that labeled as 69149 Papa, and it comes with a non-contact voltage indicator and a receptacle tester. We'll go over those at the end of the video in case you're not familiar with their functions. This is not a sponsored video. I'm going to be giving you my opinions, good, bad, and everything in between on this meter. So far for the price, I don't know if it's tariffs or what, but I walked out the door about $43 and some change for the kit, and I think that is well overpriced for the capabilities of this meter and the setup included, and we're going to go over why I feel that way. Although some notable features and things that I do like, it does feel like a durably well-made meter, so if you drop it a lot or if you're using it in an environment that is not kind to electronics equipment, should be pretty good. It does have a micro-amperage measurement setting and millivolt setting, and that's about where it ends. It doesn't have a backlight. There's only a hold function. There's no capacitance. All of your amperage measurements are only rated for DC. I don't know. It has this 1.5 and 9 volt battery test setting. I think that's kind of a gimmick. I don't know. I don't know what's going on, why it's priced so much, which I'm not a big fan of. It can be really confusing for people new to testing, but that's okay. That's what this show is for. I'm here to walk you through all of it, all the different symbols, everything that it means, and how to use it. And we're going to use practical examples to help walk you through so you can get the most out of your Klein Tools MM300 manually selecting multimeter. So let's go ahead and get started. Oh, I will say I do like that they have segmented these sections for the user. The last Cobalt meter I did, they didn't do that. So what this is saying here, so we have a volts AC section here, and because it's manual ranging, I want you to get in the mindset of think up to that number, okay? So I'll give you some examples. So we have a 200 volts AC test setting. So I want you to think this setting is good to test up to 200 volts AC. If you're going to be testing anything more than that, you should utilize these up to 600 volts AC test setting. That kind of makes sense. Another thing that I want you to keep in mind when utilizing a manually selecting meter like this is start big and then work small. So if we're going to be testing an AC voltage and we're not sure how much voltage is going to be there, utilize the biggest setting, start at 600, make a measurement of your AC voltage. Let's go ahead and just do an example here. Man, no backlight on this thing. Okay, so we can say, okay, we're in the up to 600 volts AC. We have a measurement of 118 volts AC. Looking pretty good. If I want better resolution or a more accurate measurement of what's going on here, then I can go ahead and put it down to 200 volts AC. And now you can see that we have to the tenths placeholder, and it's a much more accurate reading. So the way I like to explain it is think of it as a manual selecting meter is like when we're using a microscope. We're going to start big and far out, and it's going to be kind of fuzzy, everything in the background. And as we fine tune our microscope, we're going to bring things into clarity so we can get a really clear idea of exactly what's going on. Some notes about measuring volts AC is polarity is not going to matter whether you use the red lead or the black lead for your hot and for your neutral. Your measurement's going to come back the same regardless, right? Because the current and voltage for an AC circuit are alternating. So it doesn't matter, only for DC measurements. I'm sure you're curious about that little port there. We're gonna get to that when we get to current measurements, but just keep in mind, 99% of the time, this is how you're gonna configure your multimeter test port leads. It is nice that these are fused ports. You always wanna look for that, but it's not a true RMS meter, which is sad, which means your AC measurements aren't necessarily going to be the most accurate, but that's okay. So next up, we're gonna have, so this covers our AC voltage test setting, right? This is segmented into like a little block here, a little chunk. And then this next little block is going to be for our diodes and continuity. And they are one in the same. Man, that is brutal. Usually there would be like a function button or a selection button, and you would select one or the other. They have migrated them into one total setting, so you don't have that option. Let's go ahead and do some examples of what is continuity for and what is your diode setting for. Okay, let's do an example. Let's check our continuity. Okay, your continuity setting should emit a tone when there's contact, and the tone shouldn't be dropping out at all. Okay, that was kind of a rough start there. What is this good for? Well, it's good for identifying a bunch of different wires in a bundle, but we can also use it to be like, okay, which wire goes where? Well, that one's not to that. Oh, that wire goes to there. So we have continuity, we have flow going to there, and then we can do that. So it's great for identification. A lot of people will use continuity for verification of like wire integrity or conductor integrity, and that's not always the best idea. Let's say you have some wire that's compromised, some stranded wire, and let's say there's 50 strands in this wire, and this wire's cut, and there's only one strand left. It'll still test good for continuity. So continuity is not a great tester. It's good to get like a feel for a circuit, how things are wired up, which things go where, and then you can do your testing from there. And then let's go ahead and check out this diode setting. We always test our diodes in both directions. Okay, and what we're seeing there is the voltage drop across this diode. And mind you, that is not accurate. Let's go ahead and bring up another meter. That should be reading, if memory serves me correctly, 580 millivolts. Somewheres around there. And it's done it with every single meter I've done this show with. 547, excuse me, not 580. 548. And this meter is coming back just all over the map. I am really not liking this meter. That's really unfortunate. I love Klein as a company. I love their tools. I even love their other meters. I am not a fan of this meter. I'm so disappointed. So if you needed to accurately do diode testing, don't count on this meter. But if that's all you got, then we'll keep on going, and then you go ahead and test your diode in the other direction. And we should see that OL. That OL is going to mean out of limits, basically open circuit. There's a few different meanings for OL depending on the context of the test that you're doing. Okay, let's get to something a little more exciting. We're going to be doing some current measurements, and this is going to take a little bit of a minute to explain, but it's going to be really important to understand how to perform this test so that you don't break whatever you're testing, and you don't want to pop one of the fuses in your meter, because then that's another trip down to the big box store to go get meter fuses or return it and get a meter that actually is worth something. I'm also giving this meter a hard time because it's so expensive. If this meter was $10, which is about what it's coming back of its value of, then that'd be fine. Great, $10 meter, it's basically disposable. For the price that we had to pay for the whole kit, at this point, I definitely would recommend taking it back. Not worth it. But we will press on and continue to go through all of them. Let's see. Okay, so we have that funky looking U that can be a little intimidating. That is for micro, especially for us here in the US. We're not used to the metric, and all of the meters are in metric settings. And this lowercase m is for milli. To start big and go small would be here, 10 amps. This is in whole numbers. 10, then 200 milli, up to 200 milli, up to 20 milli, and then up to 200 micro. So it's going down and down and down in value, smaller and smaller, smaller numbers. And I know it's confusing because you see the 200 versus the 10 and you think it's a bigger number and it's a whole thing. So you want to pay attention on your meter, especially for manually selecting, to the U, the lowercase m, the K, the uppercase M. They're all going to be indicating different units of measurement. So we want to be super careful about that. Let's go ahead and do some current measurements. Now, in the spirit of starting big and going small, let's actually start with a different load. I'm going to be moving my red lead port over. Red lead port, I'm going to be moving over to here so that we can start big with up to 10 amps and then move our way down. And then something that you can note as you're making your measurements is if you see your measurement is under 200 milliamps, then you would move this lead back. Don't worry, I'll give you we'll do plenty of examples. We're going to drill it into your head until you get it. Let's go ahead and get some power going here. Okay, so with current measurements, we have to do them in series with our circuit, okay? So that basically means is that we're going to use the wires of the meter to complete the circuit. It is a live circuit, so be careful. And this is also, take note, I don't know if I said it yet, this is only rated for amperage DC. That's what it means. So think automotive, small electronics, things like that. Nothing coming out of the outlet or being powered by your house. You should be trying to make current measurements with this. It's just not what it's rated for. So we'll bring this to the 10 amp setting and then we'll work that wheel down. We'll go ahead and apply power to this bulb. Okay, 2 amps, that is actually accurate. And then we can apply to this motor. So 0.45 amps, another way to think about that is 450 milliamps. So we're still over double the amount of current rated for this port. We want to keep that in mind when we're testing, and we also want to be careful of creating short circuits. 450, so it's still above what that port's rated for. We're going to keep it on this setting. We're going to bring in some smaller loads. I'll use some resistors. They make great examples for small loads because that's one of 3 different examples of what an electrical load is. You have inductive loads, you have capacitive loads, and you have resistive loads. Those are your 3 different types of electrical loads. And they do a bunch of funky things. Now let's take another measurement. Let's get an output here. Okay, so now we can see 12. So 12 would mean, and I can press this hold button here, 12 would mean 120 milliamps, which is less than the 200 milliamps that this port is rated for. So I can go ahead and swap this little guy over here. We can set it to our 200 milliamp DC amperage setting. Take off the hold button. We can redo our measurement. And it doesn't indicate that it's in a milliamp setting. Even the cheap ones do that. Man, this meter is garbage. Klein, you're officially on notice. Take this meter off the shelf. Okay, let's redo that. So we're gonna see that 121, 22. We'll call it 123. We have our smaller and smaller settings, so we can go ahead and we got two more samples here. Okay, so now we're at a 12 milliamps, which is less than this 20 milliamp setting. So I can set it to there, and I should be able to read it to the hundredths. So 12.11, 12-ish milliamps there, okay? And then we can put it to another example here, even smaller. And I believe this 200 microamps is not gonna be enough. Yeah, out of limits. So 200 microamps is very, very small. I do like that it has that setting, but I'm not getting the warm and fuzzy about this meter. Getting a lot of red flags. Don't know how much I would trust that measurement. So let's go ahead and keep moving on. We've got these battery settings here on the meter. And what would be the difference between a battery test versus just a normal voltage test? Well, the impedance of the meter, we can even take a look at what it would be, is, I love this Klein, but it just gets such bad glare on my workbench for these videos. We can take a look and see what the impedance of the meter is going to do. So basically on this setting, okay, so for our 9-volt battery setting, it's going to put a 1.5 kiloohm. We're going to go over ohms here and kiloohms and MegAohms and all that stuff here in a minute. But basically 1,500 ohms of internal impedance to the meter will be placed on the battery as a load test. And then for our 1.5 volt, it's going to give it a 12 ohm impedance load test to the 1.5 volt battery. So that's the difference, as opposed to if I had it on the voltage setting. We'll go over those here soon. That's a 1 MegAohm setting. We can go ahead, we're on the 9-volt test setting, and we can measure the voltage of our battery, and there should be a certain amount of voltage drop. 1.5 kiloohms is not much of a load at all, so it shouldn't be very much different than what we would see in our normal DC voltage setting. Couple hundredths difference. With batteries, that's not a big deal. When you get into tenths of a volt, that can be a lot more big of a deal. Couple hundredths, that's not as much. Now for our 1.5 volts, let's go ahead and take a look at what's going on there. 12 ohms is a lot to put onto a battery. So we should see a difference here. We're coming in, what? We'll say 1.44. And if we do it with just our normal voltage settings, 1.57. So I would say that's a large difference for relative to the amount of voltage that this battery has. So that is more of an intense load test. So at least we'll give them that. The 1.5 volt battery test setting on this thing is quite the beast. Okay, now we're going to go over the resistive value settings. Again, it's something we want to start big and then work our way small, but we really want to be cognizant of the value that we've set here. So if I put it to 2M, that's 2 MegAohms of resistance, up to 2 MegAohms of resistance, our largest value setting, and then we can work it down as we take measurements. I'm going to start with larger value resistors to make things kind of easy, because this can be a little confusing. I would recommend, if you do have a manually selecting meter like this and you don't feel very comfortable with it, set up a little bench on the counter, get a couple of resistors, couple little, like a light bulb, whatever, a couple batteries, and get some practice with it. Get comfortable with it before you actually need to try to make some measurements with it, or else you're just going to be really confused and having a hard time. I know from a lot of experience how confusing it can be. Polarity does not matter for these types of measurements. I'm in the 2 MegAohm setting. So this does not mean 1 ohm, 1.046 ohms. This means 1,046,000 ohms. So we want to be really careful with that. Let's try another one. Still in the 2 MegAohm setting. So this would mean 98,000 ohms of resistance. Okay, that can be really, they're not really setting you up for success because there's no indicator on the screen, the fact that you're in MegAohms. So at a glance, you can get bit. Okay, and our next setting down is 200K up to 200,000 ohms. And that is still greater than the value that we have here. So we can go down to that and get a more accurate reading. So now it's saying, okay, we're actually at 98,000 even, basically. Okay, so let's move on to another one. Okay, we're in the 200,000 ohm setting and it says 9.9. What is your guess for what that means? That would be 9,900 ohms. Okay, or a 10K ohm resistor is probably what's put there. Now we have a 20K ohm setting. Let's go ahead and try that. So now we know it's 9,920 ohms of resistance there. Let's try the 2K. Should be out of limits. So when you have an out of limits, we want to be careful. It doesn't necessarily mean that there's no voltage or current or anything like that. Could just be a wrong setting, not a high enough value. We'll put it back to this 20K and let's step it down again. So what is this trying to tell us? We're in the 20K setting and it says 0.97. That's going to mean 970 ohms. I know I'm beating the dead horse into the ground, but man, I don't know about you guys, but for me, that's how I learn it. So this one is saying that it's 320. It's well under this next setting here is a 2K. I set it to the 2K ohm setting. Now it says 324 ohms. Beautiful. We'll go to this last one here. Last one's saying 99 ohms. Put it to the 200 ohm setting. It's really 99.1. Those are the resistive measurements. And then lastly, we have volts DC. Again, I'm going to get it into your head. We're going to start with the largest setting and work our way down. We'll start with something, let's do something a little bit more exciting. We'll bring a battery over here. These lightning bolts are to warn and indicate that a circuit could be potentially live. We're on the 600 volt DC setting and we're getting a 13 on the screen. What does that mean? Well, it just means 13 volts because there's no unit, right? It's not like 600 megavolts or kilovolts or millivolts or anything like that. It's just 600. So that's what we have here. We have 13 volts and then we can keep walking it down. And as we walk down the meter into smaller and smaller values, we'll get more and more placeholders for our measurement. So I have a 200 up to 200 volts here. Now I can read to the tens. Oh, it's 13.2 volts, not that 12, 13 wishy-washy that we had before. Okay, well, 13 is still below 20, and I know that this means up to 20 volts DC, so I can go down even further and read to the hundreds. Okay, so it's actually 13.3334 volts. The difference between a 13 volt charge and a 12 volt charge and 11 volt charge are very big differences with batteries, right? So it can be really handy. Then if I go to 2 volts DC, this value is well above 2 volts, so I should be anticipating an OL. And I do. I can go to something that I know is a value less than 2 volts, like my 1.5 battery here. And I can read it to the thousandths, 1.589 volts. And then there is a 200 millivolt setting. And then I did demonstrate kind of the hold button there. And that's great for, take a measurement. Let's do it backwards so we can just explain this really quick. If you are measuring your DC polarity backward, or you're reading negative voltage, that's where you'll get that negative sign for, okay? And then really quick, oh yeah, so that's all that. Really disappointed with this meter. Very overpriced, very inaccurate. Let's go ahead and move on to our hot stick non-contact voltage indicator. I'm not a big fan of these. It's a really good way to get zapped and get really confused, especially as a beginner. You'll see pros use these because they just have a lot of experience and they know how to read it really well. But if you are an amateur, you're not going to necessarily know how to interpret its readings. Although they have gotten better and more accurate, I will give them that. The last one I tried out wasn't terrible. But a non-contact voltage indicator is basically what the name implies. It is a way for you to not have to make direct contact with like a test lead or something like that. Let's use that in examples instead. Not having to make direct contact with the test lead, you can just get near a hot and it should tell you if it's alive. And that can be handy for sorting out your hot side versus your neutral versus your ground. Okay, these are all dead. These are all hot. But always confirm with your multimeter because they can give you false positives and false negatives, and that's why you can get zapped. So always double check. And then if you're not familiar, I mean the receptacle tester, I think if anything, if you don't have really any experience, electrical experience, this is all you really need. It's to tell you everything you need to know. Always make sure to use your receptacle tester directly into the outlet and not into an extension cable or a power strip. Power strips can often have the hot and the neutral switched. I've seen it a number of times. So you don't get a false positive or a false negative, do directly into the outlet that you're trying to test. Not like I'm doing here. And it's pretty straightforward. It's just going to go ahead and tell you, you know, in your AC circuit, you're going to have your hot, your neutral, and your ground. What's going on here? Did my bulb burn out? No. Right, your hot is your power feed from the panel. Your neutral is basically your common. That's a way for the flow to get back to the source, right, to complete our circuit. And then your ground is for your safety. You're going to need all three unless your house is super old and it doesn't have a ground, which in that case, you should probably think about contacting a certified electrician to upgrade your wiring. But open neutral basically means your common side is open. Open hot just means your power feed is missing. If those are switched, that's not good. Make sure to correct that. And open ground is no bueno either. So pretty straightforward. These things are really bulletproof. They can be really inexpensive, perfect for a DIYer. I am a really big fan of these, so use your receptacle tester. It's a very handy device. Anyways, thank you for joining me in another adventure in the garage. If you have any questions, comments, or concerns, or if you have the Klein Tools MM300, let us know your thoughts on it. It's pretty rare for me to get that many bad readings and red flags off of a brand so trusted and for such an overpriced piece of junk. So if you do have it, find a way to return it or make a complaint or something. Anyways, leave me a comment, question, concern. If you found this video helpful, give me a thumbs up. If you didn't find it helpful, give me a thumbs down. I always appreciate the feedback. Thanks for joining me in another adventure in the garage, and I'll catch you on the next one.